Hopefully you're doing okay. Let's go ahead and work through the next one. The next one will be number 4. We have CuC2H3O2. That seems like kind of a beast. Let me scoot this over here. Alright, so we just start at the top. This time I'm going to use blue marker. I do not know, but it will not erase. Drive me crazy. Alright, so does the compound contain more than one type of atom? Yes, it does. Goodness gracious. Give this a shot. Hold on. Alright, let's give this a shot again. Alright, so CuC2H3O2, that is definitely more than one kind of atom. Oh, gracious. Hold on. This is completely out of control. Oh, I love technology. That's what I get for trying to overachieve. Alright, it does. Pretend that's a pretty arrow pointing down. It does have more than one kind of atom. It has copper, so it does have a metal and a non-metal, so I'm going to go down. Are there more than two types? Certainly I have copper, carbon, hydrogen, and oxygen. I'm not looking at it, but I'm pretty sure that's what it was. So yes, it has more. In this box over here is the first atom, a member of family 1, 2, aluminum, zinc, silver, or cadmium. It is not any of those, so we end up in this box. Okay? This box is a little bit complicated. If you can figure this box out, you can figure this one out, and that one out also. They're not too difficult. Just pay attention to what it's saying. So, what it says multiply the charge of the polyatomic by how many units there are. Alright, so let's come over here and write on this one. So, the polyatomic ion that we have here is this part right here, the C2H3O2. We would get that from our periodic table, or our naming schemata, and we would call it acetate. Okay? Acetate would be found in the -1 family. Okay, so over here it says multiply the charge of the polyatomic ion, so remember it's a -1. We're going to multiply it by how many there are. If this was in parentheses and there was a number right there, that's what we would multiply it by. Now, since there is no number, that means it's 1. So I'm going to take 1 and multiply it by -1 because there's only one acetate. Right, that's easy math. That equals -1. Okay, so I did that first part. Now it says divide the absolute value of this number by the number of first atoms. Okay, all right, the absolute value of -1 is 1. We're going to divide that by how many coppers there are, and that happens to be 1. This is a whole lot of work for nothing. All right, if I multiply and do all that crap, -1 divided by 1, and the absolute value is just 1. Change this number to a Roman numeral to follow the element name of the first atom. Okay, so we put a Roman numeral 1, and it comes after the first atom, which is copper. Then name the polyatomic ion. So copper 1 acetate. That's all we have to do. Alright, that may have seemed really complicated, but look at number 9. Number 9 is going to end in the same exact box. So let's do the exact same thing as it says here. So first we need to find the charge of NO2. If you find the NO2 on the other side of your naming schemata, it is also a -1 charge. But this time we need to multiply it by 2 because there are 2 of them. That gives me a -2. I'm going to take, the rules tell me all this, take the absolute value of that number and divide it by the number of cobalts. Since there was no number with cobalt, it's a 1. That equals 2. I turn that to a Roman numeral. It follows the name of the metal, so cobalt, 2, and this is NO2, which is nitrite. So cobalt 2 nitrite. Alright, those are difficult. You can certainly do them. Good luck.